Hello everyone, my roll number is 159 and today we are going to see Fourier sine transformation example. So here we have taken a Fourier sine transformation example. First of all, we have to find Fourier sine transform of e raised to power minus mod x, and after that, after finding the e raised to power minus mod x, we have to solve integration from 0 to infinity x sin x upon 1 plus x square dx is equal to pi e raised to power minus m divided by 2 in where m is strictly greater than 0. So let us solving it. First of all, whichever the function they are given to us, let's write it here. And then after that, by using the Fourier sine transformation of fx formula, fx bracket lambda is equal to integration of 0 to infinity f of x sine lambda x dx. Here they have given us a Fourier sine transformation. For that we have using Fourier sine transformation formula in it by representing s over here. So here we have seen that our function e raised to power minus mod x. So due to this mod x, we have to find limits about it. If here we have seen if our variable x is in the mod. For that, if variable x is minus, then after getting it out, it becomes minus into minus plus x. If our variable x is positive, so after it getting out, it becomes minus x. So to find out its limits, let us consider a number line where here is 0, and after that, if our x is positive 1, then after getting it out, it becomes minus. So it goes in minus infinity, it goes in this direction with minus infinity. And if our x is positive negative x, then after it getting out, it becomes positive x which going at this direction with positive sign. So in this example, our x goes in the interval of 0 to infinity. Therefore, our function of e raised to power minus mod x is become e raised to power minus x. So just by putting our f of x value in it, just by putting our f of x value in Fourier sine transform, we get this equation. Afterwards, getting an integration of 0 to infinity e raised to power ax sin bx d with respect to dx is equal to e raised to power ax upon a square plus b square in bracket a sin bx minus bx cos bx.
My roll number is 160. So using this formula, our value of a is minus 1 and value of b is lambda. So putting this value, f of s lambda is equal to e raised to minus 1 upon 1 plus lambda square into minus sine of lambda x minus lambda cos of lambda x. Integration varies from 0 to infinity. So here putting this upper limit and lower limit. So first putting the upper limit infinity. So e raised to minus infinity is equal to 0. So here whole term is becomes 0. So here putting the lower limit starts from the negative sign. So putting the lower limit 0 is equal to e raised to minus 0 is becomes 1. So here 1 upon 1 plus lambda square. So by putting the lower limit here in place of variable x, so sine of 0 is equal to 0 and cos of 0 is equal to minus 1. So here minus 0 minus lambda. Here by solving this minus 1 minus lambda is equal to plus lambda. So here plus lambda and 1 plus lambda square as it is. So formula for the inverse Fourier sine transform is f of x is equal to 2 upon pi integration varies from 0 to infinity f of s lambda into sine of lambda x d lambda. So here our value of f of x is equal to e raised to minus x, and our value of fs of lambda is equal to lambda upon 1 plus lambda square. By putting this value, we will get, so now changing x to m. by putting the value of in place of x is m, so e raised to minus m is equal to 2 upon pi. Integration varies from 0 to infinity lambda upon 1 plus lambda square into sine of lambda into m d lambda. So 2 upon pi is shifts toward the right hand side. So here integration varies from 0 to infinity lambda upon 1 plus lambda square into sine of lambda m d lambda is equal to pi upon 2 e raised to minus m.
My goal is 161. We can say that the say example of sine transform of e raised to minus a divided by x. Now here if a of x is a e raised to minus a x divided by x. So now we can use here the Fourier series transform is given by. Now we know that the Fourier sine transform we are denoted by the lambda. So a of s lambda is equal to a integration of f of x sine lambda x is equal to the function of the e raised to a x divided by sine lambda by x. Now we are differentiated both sides by the lambda. So we get when we are differentiated both sides by the lambda. Therefore, ds is equal to function of lambda is equal to we are differentiated both things. But we know that the function of x is a constant. Therefore, we as it is of the constant of x, and we differentiated the sine lambda x. We know that the differentiated of sine lambda x is equal to x cos lambda x. Now here we can see, yes, here there are some is a constant. We are know that the a raised to ax. First of all, dsx and dsx is a cancel from the outside of the integration. Now we are know that the a raised to minus ax cos lambda x in integration here is a raised to ax divided by a square plus bx square a bracket a cos bx plus sin bx. Now we have the port of the limit for the lower limit is a 0 and upper limit is a infinity. Now we have the port of the limit to the function of the f of x. Now first we have the putting the limit of a infinity, that is the upper limit, minus the limit of the 0, that is the lower limit. Now we can put the a infinity into the ds function. Therefore,
when we get derivative of d upon lambda, f of s in bracket lambda is equal to a upon a square plus lambda square. When we take the derivative from left hand side to right hand side, we will take the integration, and we will take the a term common, and we know the value of the derivative of d lambda upon a square plus lambda square. The value is a into 1 upon a tan inverse of lambda upon a plus c, which is the formula of the derivative of x upon a square plus lambda square. After that, we will cancel both the terms a, and we will get the final answer tan inverse of lambda upon a plus c. F of s in bracket lambda is equal to tan inverse of lambda upon a plus c. We will just substitute the value of lambda equal to 0 and f of s equal to lambda equal to 0 in the equation 1, when we see the which we see first, and then we will get the value c equal to 0. When we put the c equal to 0 value in the above equation, which is tan inverse of lambda upon a plus c, we will get the term tan inverse of lambda upon a, because the c is 0. Or when we put the value of lambda from the first equation, f of s, we will get the final term f of s in the curly bracket e raised to minus ax upon x equal to tan inverse of lambda upon a, which is our final answer.